Hello, and welcome back to Math 7 with Mr. Passon. Today we're working on Unit 7, Lesson 2. We're talking about the area of a circle. Now, let's remind ourselves what area is. Remember, area is the number of squares it takes to cover up a shape. So if we had a square that was length 1 by 1, we would fill it up and we could cut and rearrange the squares till eventually they filled up this entire shape. And that would take a certain number of squares. It might take a square and a part of a square, and we're going to figure that out. So today we're learning about the formula for the area of a circle. And we can derive it, and derive means to sort of figure out by splitting the area, by splitting the circle into smaller segments. So we've cut it up sort of like a pizza, and we rearranged it. And we say that, hey, well, what shape does it sort of look like? Well, it looks like a parallelogram, which you probably learned about last year, and the area of a parallelogram equals the base times the height, right? So if we cut these segments smaller and smaller and line them up the same way, you'll notice that half the wedges are pointing up and half the wedges are pointing down. That means this curve along the bottom is about half the length of the circumference. So I'm going to put 0.5 to represent half, times the circumference, times the height here, and the height here is 1 radius. Alright? But we have a formula for the circumference. We have 0.5 times the circumference is 2 times pi times the radius. That whole part there is the circumference, and then times the radius again for the radius on the outside. So this part right here, that part is the C. Alright, that part right there is the C. Now, 1/2 times 2 is just 1. And so then we've got pi times the radius times the radius. Now, anytime we have a number times itself, we could use that as an exponent. And I want to introduce some of that notation, but we're not used to it a whole lot. So we could think of it pi times r. We use this little caret symbol. It's above the 6. So shift 6 to represent an exponent. And then the way that we actually write that most often, let me just grab another place to see this. So let me just grab a tool over here where we can write what it would normally look like. So we would normally write it pi times the radius squared. That is our area formula. Area equals pi r squared. Okay, so that is how we would write it if we were handwriting it. And you'll notice that we've got the pi here, the r, and then that little symbol to represent an exponent. And remember that the exponent means this is r times r. If there was a 3 up here, it'd be r times r times r. Oh. So, based on the diagram, how is the circumference of a circle related to the length of the parallelogram? Well, we've noticed here that the length here includes half of the wedges. So the length is half the circumference. Right? So that's where we got 0.5c. That is our base. Okay? Now, the area, as you recall, of a circle measures the covering of a two-dimensional object. So here you can see the little squares, and we could count basically how many squares it takes, or we can use the formula. You'll notice the formula is based on the radius. So if you don't know the radius, you have to find the radius. Alright, now we're going to use our formula, and it's A equals, now I'm going to insert that special character, just because it's probably good for us to have it. and I am going to use, not that one, I want the bold one. Where's the bold one? Well, maybe I will use that one because I can't see the other one. That one there. No. There we go, if I make it bold. Times R. And then I'm going to insert another text box to represent my exponent. Make that text box size something much smaller. Maybe not quite that small, that's way too small. And move it up there. And maybe get rid of the border. No border. Pi r squared, where r squared is equal to r times r. Alright? So, that notation, that exponent means r times r. And honestly, while we're typing, we're probably going to write r times r, just because it's easier than trying to figure out how to get that exponent. Now, let's figure out our formula. So, a equals pi times r times r. Let's plug in our value. So our a equals 3.14 times, let's see what our radius is. Well, it's 1, 2, 3 units, and they even told us our radius was 3 inches. So times 3 times 3. We need to do that calculation. Alright, so let's do 3.14 times 3 times 3. And I'm going to pull up a calculator real quick here. So 28.26. 28.26. And that is square inches. Okay? Square inches. Because that's how many, it would take 22 and a little bit more than a quarter of a square. So 28 of these and a little bit more to fill it up. Again, we're going to use that same formula. A equals pi times r times r. So our area equals 3.14 times 5 times 5. Now, why did I use 5? Because this clearly says 10 there. Think about that. Why? And I'm sure some of you got it. That radius, the distance from the middle to the end, is half the distance all the way across. This 10 was the diameter. So that was kind of a sneaky, like it wasn't meant to be sneaky, but you have to notice that. The number that they gave us was not the number that we needed, but we could figure out the number that we needed. And here, when we multiply that out, we get 78.5 square centimeters. Alright. Last one, well here the radius is 6, so we're going to use that same formula. So we've got a equals pi times r times r. So our a equals 3.14 times 5 times, or not 5 times 6 times 6. Let's do the work. And there we get 113.04. Alright. Now, look at this. This is meters, so this is square meters. Now, that is the same as saying a meter to the second power. Okay? So just like we had an exponent before, we could think of that as, and I'm going to grab it from here. So if I say square meters, well, that is going to be the same as meters raised to the second power, meters squared. Okay? And that's sort of where it comes from, actually, this notation of talking about something squared. It's the area of a square with a length of 1 meter on the side. So that exponent It definitely comes from this idea of covering things with squares. Okay? Now, I wish it were super easy to insert an equation in here, because Google actually has a whole great equation editor, and I'd show you how to do it, but they didn't put it in slides, which is really a disappointment. Okay, so let's go ahead and go on to page 2. Ooh, word problems. So let's look at these and see if we can figure out how to handle it. Come back and if we have the calculator if we need it. Alright, so the area of a circle can be given and require you to find the parts of the formula by solving the equation. So we could know part of the problem, and we have to go back and figure out the rest. Alright, a circle has an area of 78.5 square inches. What is the radius? So we could say, well, RA equals pi times r squared, right? Well, that means our 78.5 equals 3.14 times r times r. Now let's go ahead and figure out, well, let's do the 78.5 divided by 3.14. Alright. Well, that is 25. So 25 equals r times r. Do you know of a number that when multiplied by itself is 25? What number times itself is 25? Oh, I think you know it. 5 equals r. So our radius is 5 inches. Now, if the area is in square inches, then the radius has got to be in inches. Let's look at this one. A pizza has a diameter, so D equals 18 inches, right? It's then cut into 8 equal pieces. About how many square inches is each slice of pizza? So a slice is 1/8 of a circle. So let's find the area of the circle, or let's say the slice is then 1/8 of pi r squared. Now they told us the diameter. We need to know the radius. And I'm going to change that for r times r just to remind ourselves. So the diameter is 18. That implies that the radius is half that, is 9. So we need 1/8. So the area of a slice equals 1/8 times 3.14 times 9 times 9. So here is the area of the whole pizza, and then we break it into 8 pieces by multiplying by 1/8. I'm going to use a calculator real quick, do that calculation. Alright, so I have got looks like about 31.8. Okay, about 31.8. Square inches. Alright, let's look at this one. A circular rug measures 8 feet across. What is the area of the rug? So we know A equals pi times r squared, or r times r. But we also know the diameter equals 8. Well, that implies that my radius, well, my radius is always half my diameter, is 4. So my area is 3.14 times 4 times 4. Again, I'm going to do that calculation using the calculator. And that I get is 50.24, and that is going to be square feet. Alright? Now, two different circular fountains are being considered for an outdoor patio. How many square feet will the larger fountain occupy? So we need to know, so we know the diameter of one, and the radius of two. Radius. Put in an extra letter. What I need to know is the difference in the area. So let's find the area of each one. So area of I, or 1, and area of 2. We're going to use the same formula, pi times r for both of them. But we only were given the diameter of one. The diameter of one is 16. So the radius is half the diameter. So the radius is 8. So we got 3.14 times 8 times 8. And this one is 3.14 times 9 times 9. Now the difference is, let's go ahead and do those calculations, then we'll subtract to find the difference. This is the smaller one, so I'm actually going to put it second. So let's go ahead and figure out. So I've got minus 200.96, and then let's do 3.14 times 9 times 9, and this is 254.34, and then we're just going to subtract. And we get 53.38 square feet. So the difference, and we could say fountain 2 is 53.38 square feet bigger. Alright. Now, I'm going to check my math on that real quick, because the one that I did earlier, I got a different answer. Nope, I actually got them both the same. I was just reading the place off the wrong spot. So, think about how you can use the formula. You're always going to start with the model, so anytime you're using... Ooh, and I misspelled formula. This is why it's better to have students in class. I don't do that. You guys all catch my mistakes if I make them in class. So, remember that you're going to be using this model, okay? Area equals pi times r squared, or area equals pi times r, and you're going to be solving for one of the pieces. I might tell you the r and you can figure out the a. I might tell you the a and you can go back and figure out the r. In either case, you're going to have to be able to figure out the missing piece.